The position vectors of points P, Q, and R are I minus 2j plus k, 3i minus j minus k, and 7i plus j minus 5k respectively. Find the angle between OQ and PR. 4 marks. Item 2. Show that PQ and R are collinear. Item 3. Given that the vector lambda I plus 3j minus 4k is perpendicular to OP, find the value of lambda. 2 marks. On part 1, we are going to use the formula cos theta is equal to OQ dot PR over OQ dot PR. This is the formula for calculating the angle between OQ and PR. You say the dot product over multiplication of the modulus for the two. The problem arises when we have OQ but we don't have PR. So how can we calculate PR? PR, we just use the method for calculating the displacement vector. PR is a displacement vector. So PR is equal to OR minus OP. OR minus OP. In the previous tutorial, we learned how to calculate PR. So our OR is equal to 7, 1 minus 5. From the vector form, we change it to the column form. And also OP is equal to 1 minus 2, 1. Then we say 7 minus 1, 1 minus 2, negative 5 minus 1 is equal to 6, 3, negative 6 in column form. Now we have PR and OQ. Let's substitute them. Cos theta is now equal to 3 negative 1 dot 6 3 negative 6 all over the modulus of 3 negative 1 and 6 3 negative 6. You see that our 3 is here, 3 squared, negative 1 is 1 squared. We don't care about the negative sign when we are calculating the modulus because we are always going to square it, so the modulus is no use for us. Now the dot product on top, we put 3 brackets and multiply the corresponding vectors, direction vectors. Then it's 3 times 6 here in the first bracket, and in the second bracket it's negative 1 times 3. In the third bracket it's negative 1 times negative 6. Then all over, if we simplify the everything in the square root, we are going to get root 11 dot root 81. Now if we further simplify it, we are going to get 21 over 9 root 11. It's now arc cos of 21 over 9 root 11. Since it was cos theta is equal to this expression, so it's now arc cos. We can also use a calculator to calculate this. It's now 45.3 degrees. Moving on to item 2, the question requires us to show that PQR are collinear. There are 2 methods that you can do to show that they are collinear. The first method is you find PQ, then you find PR. PR, we already have it. It's 6, 3, negative 6 from our previous workings. And PQ, we have to find it. So it's OQ minus OP. Then we substitute and solve. Collinear means they exist in a same line. So you have to see something unique here. So uh, notice something here, that if you multiply PQ by 3, you are going to get PR. If you say 3 multiplied by 2, 1, negative 2, we are going to get 6, 3, negative 6. So it's 3 multiplied by PQ, we are going to get PR. Then the conclusion is 3 multiplied by PQ, 3 multiplied by the vector PQ is equal to PR, 6, 3, negative 6, which is equal to PR. And hence, they are collinear. They are collinear. And the second method, you find PQ, but PQ we have already found the vector. So you find PQ, then you find QR. You find PQ, then you find PQR. Sorry. Now you say OR minus OQ, which is equal to 4 to negative 4. Now you notice something unique again. That's the second method. You see that uh, uh, if you multiply PQ by 2, you will get QR. Multiplying PQ by 2, you get QR. Let's see it. Multiply by 2, which is equal to QR, which is equal to QR. Therefore, 2 PQ, 2 times vector PQ, don't forget the arrow here, the arrow, which is equal to vector QR, vector QR, vector QR. Now we can write the conclusion. Let's say hence they are collinear. Attempting the last part, we want to find lambda if the given vector is perpendicular to OP. We know that the dot product for perpendicular vectors is equal to 0. So if we say the given vector dot OP, the OP we have been given, it's 1, negative 2. Then we solve to get the dot product. Is lambda times 1 in the first brackets. After you put 3 brackets, then it's negative 2 times 3, then it's negative 4 times 1, which is equal to 0. That's the dot product for perpendicular vectors is equal to 0. Now it's like an equation, we can solve it. It's 1 multiplied by lambda, it's 1 lambda plus it's negative 6 minus 4, which is equal to 0. Now solving this equation, we are left with lambda equal to 10. That's how it is done. Thank you for watching. Make sure you subscribe if you haven't subscribed to our channel.